Hello students, I am Vishwajit Nath. Welcome to my YouTube channel Best Physics Guide by Vishwajit Nath. Today I am going to discuss about the resolution of a vector into two-dimensional coordinate system and three-dimensional coordinate system. At first, when we resolve a vector into two-dimensional coordinate system, that is on xy plane, here ox and y, ox and oy are two mutually perpendicular axes. That is, the angle between ox and oy is 90 degree. P is a point on xy plane. The Cartesian coordinate of the point P is xy, and the polar coordinate of the point P is r theta. That is, the distance between the origin O and the point P is r, and OP makes an angle theta with the positive x-axis. Here O is the origin, that is, the coordinate of origin is 0, 0. We can draw two perpendiculars on OX and Y axis respectively. That is, PA is normal on OX axis. Therefore, OA is equal to small x, and here PB is normal to OY axis. That's why OB is equal to small y. Now, according to Pythagoras Theorem, the length of OP is equal to under root over of OA square plus PB PA square, OA square plus PA square, or modulus of OP gives that modulus of R vector. This is equal to under root of OA square plus OB square. This is equal to under root of x square plus y square. And x is equal to mod of r cos theta, and y is equal to mod of r sin theta. Here r vector is known as the position vector of P. Let small I cap, small j cap are the unit vectors along OX axis and OY axis respectively. Therefore, r vector, that is position vector of P, is equal to x I cap plus y j cap, or x vector is equal to modulus of r vector whole into cos theta I cap plus sin theta j cap, where theta is equal to tan inverse y by x. Here r theta is known as polar coordinate and xy is known as Cartesian coordinate of P. Here r vector is known as the position vector or polar vector of the point P. In this way, we can resolve the r vector into two mutually perpendicular coordinate system, OX and OY respectively. That is, along OX axis, the magnitude of r vector is, that is, along OX axis the magnitude of r vector is x, and along OY axis the magnitude of r vector is small y, and r vector makes an angle theta with the positive x axis, OX axis. By this method, we can easily solve many problems, numerical problems. I shall give you some examples related to this theorem or related to this formula. The problem is, a particle initially moves along east direction by 10 meter, then 5√2 meter towards northeast direction, then 20 meter along north direction. After that, 5 meter along left, then 2 meter along northwest direction. Find the displacement of the particle with respect to its initial position. We can draw the displacement vector with respect to OX and Y axis like this. Here O is the initial position, O is denotes the east towards east, OW denotes towards west, ON denotes towards north, and OS denotes towards south. That is, here WOE is along x prime O x axis and NOS along Y prime axis respectively. Here the initial displacement OA is 10 meter. After that OB is 5√2 meter. It makes angle 45 degree with OE axis. OC is equal to 20 meter. Then after left, that is towards west, OD is equal to 5 meter, and then southwest direction, that is OF is equal to 2√2 meter. It also makes 45 degree angle with NS axis or OW axis. Okay. OF also makes angle 45 degree with OW axis. We can resolve these displacement vectors into two mutually perpendicular components OX and Y respectively. Here the component of the resultant position vector along x axis is x is equal to OA, this initial displacement, that is along x axis, OX axis, OA, plus OB cos angle BOE. It is along positive x direction or positive x direction. That's why it is, we take positive sign. OD along negative x axis. That's why we consider negative direction, minus sign. OD along negative x axis. Here OF is along negative x axis. That's why we write negative minus sign, minus OF cos angle FOW. Now we can put these values, that is OA is equal to 10 meter, OB is equal to 5√2 meter, cos angle BOE is equal to 45 degree, cos 45 degree, minus OD is equal to 5 meter, OF is equal to 2√2 cos 45 degree. This gives x is equal to 8 meter. Similarly, we can find the y component of the resultant displacement vector, that is y is equal to OB sine angle BOE. Here the component of OA along OY axis is 0. That's why you start from OB vector. Here OB is also along positive direction of y axis. That's why we write plus sign or consider positive sign. OB sine angle BOE plus OC along positive y axis. That's why plus OC. And OF has the component negative y axis, along negative y axis. That's why we consider minus sign or negative sign. Minus OF sine FOW. Now we can put these values. OB is equal to 5√2 sine 45 degree plus OC is equal to 20 meter and OF is equal to 2√2 sine 45 degree. This gives 23 meter. Here the values of x and y both are positive. That's why the resultant vector along positive axis, that is at the first coordinate, the Cartesian component or Cartesian coordinate of the OP vector is 8, 23. That is the position vector of OP is 8 I cap plus 23 j cap, or the Cartesian component coordinate of P point is 8, 23. Here OP denotes the resultant displacement vector or R vector. That is OP is equal to R vector. Here OP makes angle theta with a positive OX axis. Therefore, magnitude of R vector or resultant vector, that is mod of R vector, is equal to under root of x square plus y square, is equal to under root of 8 square plus 23 square meter. This is equal to approximately 24.35 meter. And tan theta is equal to y by x. This gives tan theta is equal to 23 by 8 is equal to 2.875. Therefore, theta is equal to tan inverse 2.875. This is equal to 70.82 degree. Therefore, the resultant displacement of the particle is 24.35 meter along north, making angle 70.82 degree with east. Like this, we can solve many other problems related to the polygon theorem of vector addition. Since OX is along east direction and OY is along north direction, that's why we can say that the resultant displacement vector makes angle 70.82 degree with east towards north. Now, resolution of a vector into three mutually polar perpendicular coordinate system, that is OX, OY and OZ are three mutually perpendicular coordinate systems. That is OX perpendicular to OY and OY perpendicular to OZ, and OZ is also perpendicular to OX. Here O is the origin and its coordinate is 0, 0, 0. The coordinate of P is x, y, z. Here OP is equal to R vector is known as position vector of the point P. PQ is normal on the axis xy, on the plane xy plane. PQ is normal on the xy plane. Here AQ is normal on OX axis, BQ is normal on OY axis, and PC is normal on OZ axis respectively. Here PQ is equal to OC is equal to Z, and OA is equal to small x and OB is equal to small y. Therefore, the magnitude of R vector R is equal to under root of x square plus y square plus z square. This is the magnitude of a position vector of the point P. If we consider a rectangular parallelepiped OAQB PC, okay, this is a rectangular parallelepiped. Here OA is the length of the parallelepiped, AQ or OB is the breadth, and OC is the height of the parallelepiped. OP is the diagonal of the parallelepiped. OP is the diagonal of the parallelepiped. Here the length of the parallelepiped OA is x, OQ is y, and OB is also y, and OC is equal to PQ is equal to Z, that is height of the parallelepiped is equal to Z. OC is equal to PQ is equal to Z. Therefore, the length of the diagonal OP is equal to under root of OA square, length square, plus base square plus height square. This is equal to under root of x square plus y square plus z square. That's why we can write the magnitude of r vector is also equal to under root of x square plus y square plus z square. Therefore, mod of r vector is equal to under root of x square plus y square plus z square, where r vector denotes OP vector or position of P. Here r is the position vector of the point P. Now OP makes angle alpha with x-axis, that is angle POA is equal to alpha. Angle POB is equal to beta, that is OP makes angle beta with positive y-axis. OP makes angle gamma with the positive z-axis, that is angle POC is equal to gamma. By trigonometry, we can also write these following relations. Now let L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma, where L, M and N are known as the direction cosines of the r vector. Now L is equal to mod of x by mod of r. M is equal to y by mod of r, and N is equal to z by mod of r. Now L square plus M square plus N square is equal to x square plus y square plus z square by divided by r square mod of r square is equal to mod of r square by mod of r square. This gives L square plus M square plus N square is equal to 1. This is the relation among the direction cosines. We can show that M is equal to y by r easily from this triangle, and N is equal to z by mod of r from the triangle OPC. Here from triangle OPC, OP is the hypotenuse and OZ is the base. That's why cos gamma is equal to base by hypotenuse, OC by OP. This gives OP is equal to, this gives OC is equal to OP into cos gamma. We know that OC is equal to Z, therefore Z is equal to mod of R into cos gamma. Therefore, we can easily prove that Z is equal to mod of R cos gamma, or cos gamma is equal to Z by mod of R. Okay. Like this process, we can also prove that cos alpha is equal to x by r and cos beta is equal to y by r. Let I cap, j cap and k cap are unit vectors along OX, OY and OZ axis respectively. Therefore, r vector is equal to xi cap plus yj cap plus zk cap. This is the representation of position vector of P, and mod of r vector is equal to under root of x square plus y square plus z square. Let initial position of a particle is r1 vector is equal to x1 I cap plus y1 j cap plus z1 k cap, and after time t its position vector becomes r2 vector is equal to x2 I cap plus y2 j cap plus z2 k cap. Therefore, the displacement of the particle is r vector is equal to r2 vector minus r1 vector. This is equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Therefore, the average velocity of the particle is v vector is equal to r vector by t. With this method, we can find the displacement and average velocity, similarly the acceleration of the particle. Let ABC is a triangle. The coordinate of point A is x1, y1, z1. Coordinate of B is x2, y2, z2. And coordinate of C is x3, y3, z3. Therefore, the AB vector is equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, and the magnitude of AB side is equal to AB vector is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, and BC vector is equal to x3 minus x2 I cap plus y3 minus y2 j cap plus z3 minus z2 k cap, and AC vector is equal to x3 minus x1 I cap plus y3 minus y1 j cap and z3 minus z1 k cap. Similarly, we can easily find out the magnitude of BC and magnitude of AC by this method. Okay, today I am going to finish my discussion. Thank you for watching my video and please subscribe my channel.